Hello, today we are covering areas of parallelograms and triangles. You guys will be able to find both perimeter and area of these shapes. We are first going to start by reviewing our special right triangles. Recall from a few chapters ago, we have special rights 45, 45, 90, and we have 30, 60, 90. Now, we use these to set up a proportion and solve for missing side lengths when we don't have enough information to do Pythagorean theorem. I noticed that a lot of you decided that it would be cool to go ahead and just write these down instead of drawing the similar triangle off to the side like I did here. Just writing the pieces out right beside. Now I agree, that is pretty awesome. That's what I am going to do today instead of writing out the similar triangle for the rest of our problems like these to set up our proportion, because you can see that 10 and root 2 go together and m and 1 go together. Now you can cross multiply to solve. The thing is, when you cross multiply, you end up getting back to this same problem like this. Now, you could solve this for a decimal. I'm going to go ahead and show you the radical form just to give you some more radical practice. So we end up getting that m is equal to 5 root 2. Now a 45, 45, 90 triangle is an isosceles triangle. That means that n is also equal to 5 root 2. So there you have it. That is a 45, 45, 90. Now for the 30, 60, 90, I'm going to go ahead and label these. Across from the 30 is 1, across from the 60 is root 3, across from the 90 is 2. And then I will solve using a proportion. I'm going to start solving for y. So I have 8 divided by 2 is equal to y over 1. Notice you can cross multiply to solve. You will get right back to 8 over 2 equals y. So this is equal to 4. Now, I can use that y is equal to 4 to solve for x if I wanted. I can say 4 over 1 is equal to x over root 3. I can cross multiply to solve. I get 4 root 3 equals x, and I don't need to go any further. That is my solution for x. So we will use that a little bit later, an idea like this. Our new vocab is base of a parallelogram, height of a parallelogram, base of a triangle, and height of a triangle. So we have areas of parallelograms. In lesson 6.2, we learned that a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Any side of a parallelogram can be called the base of a parallelogram. The height of a parallelogram is the perpendicular distance between two parallel bases. So notice it has to be this perpendicular distance for our height. You can use the following postulate to develop the formula for the area of a parallelogram. The area of a region is the sum of the areas of its non-overlapping parts. So if we take a look here real quick, if we draw this in as a triangle, and we move it over here, we actually get a rectangle because this triangle is no longer here. So it's basically the same formula as finding a rectangle, which you'll see down here. Recall from lesson 1.6 that the area of a triangle is the product, the area of a rectangle is the product of its base and height. By the area addition postulate, a parallelogram with base b and height h has the same area as a rectangle with base b and height h. So area of a parallelogram is area equals base times height. Now, quick recall, area is finding everything on the inside, how much is there. Perimeter is finding the distance around the outside, okay? So find the perimeter and area of this parallelogram RSTU. So first thing we need to do is we need to take our base times our height. The problem is we don't know what our height is. So we need to solve for that. The best way to solve on this problem is to go ahead and just use Pythagorean theorem to solve, we'll call it h I suppose, to solve for the height. So we have h squared plus 12 squared equals 20 squared. Oops. End up getting 256, I believe. And then the square root of 256 is 16. So our height is equal to 16. And then the area of a parallelogram is just base times height. So 32 times 16 is equal to 512. And then make sure when you label this, it is square inches. Make sure you get that label right. To find the perimeter, it's pretty simple. You just add the edges, the side lengths. So 32 plus 20 plus 32 plus 20. You end up getting, let's see, 104 inches for your perimeter. Okay, let's do another one. Once again, we use the same process. We're gonna have to take Pythagorean theorem to find our height. Our base is given to us. It is 27 meters. Let's actually write it out. We have 8 squared plus h squared equals 17 squared. 17 squared is 289. So I believe we are going to get that the height is 15 meters. So this would be a really big parallelogram if it was actually in real life. So to find the area, take base times height. So 27 times 15, you get 405 square meters for the area. And then the perimeter, we just add up the side lengths. So 27 plus 17 plus 27 plus 17. We end up getting 88 meters for the perimeter. Okay, now the area of a parallelogram given different information. This time we can't use the Pythagorean theorem, but instead can use our special right triangle idea, hence why we reviewed that earlier. We know these sides are congruent just because it's a parallelogram, so we can use that information to find this h value. So I know this is 1, 1, and root 2. So I have 9 over root 2 is equal to h over 1, which just means h is equal to 9 over root 2. Once again, you could find this as a decimal. I'm going to write it as a reduced radical. 9 root 2 over 2, because we had a step in here that was root 4, but root 4 is 2. And you can't reduce this 9 divided by 2. So our height is 9 root 2 over 2. And our base is equal to 12. So actually I'm not going to circle that yet because I need to find my area. So the area is just base times height. If you are really on top of it, you can notice that you can cancel out the 2 and reduce the 12. And end up getting 54 root 2. There's no units. I'm going to say units squared. You could go ahead and solve that for a decimal if you chose, or you could leave it in the radical form. Either way is okay. Okay? We have another problem like that. We are going to find the area of parallelogram ABCD. So once again, we follow the same process. We have 12 as the hypotenuse. That is root 2 in a 45, 45, 90. The legs are 1. We set it up. We have 12 over root 2 is equal to h over 1. Since this is over 1, and only because it is over 1, can we go ahead and just say it is this without cross multiplying? You can't always cross multiply if you're afraid you're going to mess something up. I just know if there is a variable over 1, it's just the same thing as the variable by itself. I go ahead and reduce. I get 6 root 2 as my height. And then my base is 16. Oh, sorry, not 12, 16. So I go ahead and take area equals 6 root 2 times 16. 6 times 16 is 96 root 2. And this time we have square centimeters for our area. All right, now we're going to transition over to triangles. You'll notice in the figure below, a parallelogram is cut in half along the diagonal to form two congruent triangles with the same base and height. So because it's a parallelogram, the bases are the same. The height is the same all the way across. You can cut these triangles into two congruent triangles, meaning that they have the same area. So one triangle with base B and height h has half the area of a parallelogram with the same base B and height h. So, therefore, the area of a triangle is half base times height, or base times height divided by 2. So we are going to find the perimeter and area of this triangle. Now, there's two ways we can do it. The first way is honestly my preferred way, even though it takes a lot longer. We have the big triangle that I'm going to find the area of. So this is 46 times 30 divided by 2. I'm going to find the area of this. End up getting 690 square inches. Then I'm going to find the area of the non-shaded triangle, because I want to find the area of the shaded triangle. Okay, so I'm going to take 27 times 30 divided by 2. I end up getting 405 square inches. And then if I subtract those, I am left with the area of the non-shaded piece, which I believe is 285 square inches as my area. Now, a second way you can do this isn't my favorite way. Sometimes finding the area of triangles actually confuses me. You can actually go ahead and take 30 as your height of this triangle, this specific triangle, because it drops down to a perpendicular in line with the base of 19. So if instead you did 30 times 19 divided by 2, you will actually get the same solution. I'll show you down here. So 30 times 19, you go ahead and divide that by 2. You actually get 285 square inches as well. So that one definitely is a quicker way. I like doing it the other way because it's easier for me to visualize, but feel free to do it the second way. All right, and then we also need to find the perimeter. Now the thing is, we don't have enough information to find the perimeter of this shaded triangle. We have to find this distance, which happens to be the hypotenuse of the non-shaded triangle. So I'm going to do 30 squared plus 27 squared equals x squared. I end up getting that those squared and added are 1629. And the square root of that is not actually a perfect square. That is a-okay. We'll just have a decimal. I'll round it to the hundredth. Just pay attention to whatever the instructions say, tenths or 100ths. And then since it's the perimeter, I need to add 19 plus 41 plus 40.36. And I get my solution of 100.36 inches for my perimeter. All right, we have 2 more problems. These next 2 you are going to have to draw a picture for. So it says the height of a triangle is 7 inches more than its base. Actually, no, I'm going to use x's. So the base is x, the height is x plus 7. Find the area, find the base and the height if the area is 60 square inches. So area is equal to base times height. So I'm going to replace area with 60, base with x, height with x plus 7. We'll go ahead and distribute. Oh, but it's a triangle, so we need to divide by 2. Can't forget that part. So I multiply by 2 on both sides, and I'm going to distribute x through. Now notice we have that x squared, which means we're going to have to use either factoring or the quadratic formula. Meaning we need to get one side equal to the 0 and everything else on the other side. So here we are, ready to start either factoring or using the quadratic. I've noticed most of you like using the quadratic, so I will use the quadratic on this one. We know A is 1, B is 7, C is negative 120, so we go ahead and plug that into our quadratic. So B becomes 7, A is 1, C is negative 120. And then I go ahead and I solve. So negative 7 plus or minus 49 plus 480 all over 2. 49 plus 480 is 529. And then 529 happens to be a perfect square. It is equal to 23. So negative 7 plus or minus 23 over 2. Now we do need to solve this in 2 ways. So negative 7 plus 23 over 2. Negative 7 minus 23 over 2. The thing is, this is once again distance. So this guy, he would get us a negative distance, so that is not a good answer. So actually, our only good answer is going to be 8. So we are going to go ahead and then plug that back in and get that our base is equal to 8 inches, our height is equal to 15 inches, and we have our solution. Okay, one more just like that. We have a triangle. The height of the triangle is 12 inches more than the base. The area is 560 square inches. Area is base times height, so base is x. Height is x plus 12. Area is 560. Because it's a triangle, we need to take base times height divided by 2. You know, I should probably add that up here too. Base times height divided by 2 is what we needed to do. So we'll multiply by 2 on both sides. We get 1,120. is equal to, distribute this guy through, x squared plus 12x I'm going to go ahead and factor this one. The other one was also factorable, but I want to show you one of each type. So to factor this, I want to find factors of 1,120 that subtract to positive 12. So if I just pull up my calculator, I start trying stuff. I take 1,120, I divide that by 20. 56 minus 20 is not equal to 12. So the next thing I tried was 40, which is 28, and 40 minus 28 is equal to 12. So I know my factors are x plus 40 and x minus 28 is equal to 0. Now to finish solving, you just set each of these equal to 0. So I get an x equals 28 and an x equals negative 40. Obviously, my solution cannot be a negative distance, so negative 40 is out of the question. So our base is equal to 28, was their unit, inches. And our height is 12 more than that, so 28 plus 12 is equal to 40 inches. And there we have it. There's our solution. Have a great day.